-5 on this graph is also known as the absolute minimum because it is the smallest point of the entire graph. No point on this graph will get any smaller than that one. It's an extremely important point, especially for business people. Minimize costs and all that other fun stuff. Okay, the other two things I want to talk about are these arrows up here. What is this arrow doing here? It's going up. Which other way is it going?
To the left.
To the left. So it has that double motion going on. You have to be very cautious which one you look at when you start answering some of these questions. This arrow over here is going up, but it is also moving right. So if you're talking about x values, it's going off to infinity. If you're talking about y values, it's also going off to infinity because it's going up. Okay, so let's go through all the older stuff. What's the domain of this function?
I have a review question.
Go for it.
So, the arrow going to the left will be negative infinity, and the other one will be just plain infinity.
Yeah, but it's negative infinity on the x-axis. The other one is plain infinity on the y-axis. If you're talking about the one pointing up.
Right.
So it depends on which axis you're talking
I
about.
would have parentheses, negative infinity, then infinity signs with another parenthesis.
For the domain?
Right.
Yeah, that's it.
Oh, is that what you were asking?
Yeah, what's the domain of this thing?
Sorry.
What's the domain of this thing? If negative infinity goes all the way to the left, if positive infinity goes all the way to the right, and nothing is missed in the middle, no gaps. Okay, what's the range of this thing?
The range would be,
How far down does it go?
the range would be
-5.
-5 is as low as it goes. There's nothing lower than that absolute minimum. So -5 is the lowest. What's the highest it goes?
infinity.
Infinity. I have two of them going up there, one on the right and one on the left, but they're both going to infinity.
You said range.
Which signifies the infinity?
Huh? Oh, the arrows here.
Okay, all right.
Whenever you hit an arrow, that means infinity because it just keeps on
Keeps
going.
I got you.
So they're both pointing up, so therefore it's just going to positive infinity one way or the other. All right, the other part of information I want to talk about is this idea of increasing. Now, when we talk about increase or increasing, we're talking about one motion on this graph. You have to go in one direction. And that direction you have to travel is you have to go from left to right. You have to. So your finger has to follow the graph as it moves left to right. So as we're going from here to -5, what direction are we going? Are we going up or are we going down? We're going down. I don't care if that arrow's pointing up. We have to travel along the curve. So this is not an increasing part of the curve. So the increasing part starts at this coordinate and moves along this curve and it goes off to positive infinity. But be careful. When you say increasing and decreasing, you care less about up and down motion. You care about when does it happen. So for what x values does this thing increase? Well, it starts here at this x value, which is -5, and it increases as x goes off to infinity. So our increasing is bracket or parentheses. It really doesn't matter if you mess up the bracket and parentheses here. -5 all the way to infinity. So the graph will be increasing for these x values.
If you said it doesn't matter,
It doesn't matter when you're...
you signify a bracket on one of
Ah, now that's domain and range.
No, on this one you just read.
Oh, I'm putting it here because it is a solid circle. If you see solid circles, it's best to put brackets.
If we put the whole thing in parentheses, it wouldn't matter?
I would mark it wrong. Why? Because this point here, -5 is neither increasing nor is it
Decreasing.
because it's at the very, very bottom. You can kind of think of it as it's decreasing to it, but then it's increasing from it,
Right.
so it's really not doing anything.
Okay.
This is actually what's called a standstill point.
All right.
So if you put the parentheses, I'm not going to punish you. If you put the bracket, I'm not going to punish you.
So
What I'm looking for here is,
If you bracketed both sides.
you better not bracket infinity.
Mm.
That's just a given. But what I'm interested in with increasing is you pick the right numbers. That you pick the right numbers.
Is the increase going to be the same as the range?
A part of it. It'll always be a part of the range. No. Don't think that. I've labeled this already x values. So these numbers are different than these numbers. These are going up and down in range. These are going
Left or right?
left and right. So yeah, they're totally different. It does matter which values you pick. So what about decreasing? When is this graph decreasing? When's it coming downhill? Well, if we move from the left to the right, it's going downhill all the way to this point. So where does it start going downhill?
Negative infinity.
Negative infinity. All the way up to
Negative 5.
-5 on the x-axis. Now, if you take your increasing and decreasing and put them together, you should end up with
1.
the domain. If you put your increasing, all your increasing, decreasing together, you should end up with your entire domain. So negative infinity to -5, and -5 to positive infinity, there's your domain.
So can we safely say that the decrease will be the opposite of the increase?
Well, it definitely won't be increasing. I wouldn't say the opposite. That gets a little tricky. All right, turn the page over to those other two graphs. Let's see. Draw a pen quickly. Something like this. Okay. What are the important points in this one?
What?
I said turn the paper over. For those other graphs. What are the important points in this picture?
Oh, what do you mean? I know
What
it's
looks important?
infinity. I know.
Well, yeah, we got our infinities, our arrows, but points. What are the important
Where it
points of
crosses
this?
the X and Y's.
Not so
and-
much.
And the high and low of the.
The high and the low are really important, because especially when we're talking about increasing, decreasing, because that high-low point, the max or min, is going to change over from increasing to decreasing for the most part. So this point seems to be what's called a
Maximum.
Local max.
local maximum or a relative maximum, either one. So this is a local max. What's its coordinates?
Negative 2, positive 6.
-2, +6. -2, +6. Do we have any other special points?
We have a local minimum.
We have a local minimum over here. So we're going to call it local min. Where does it happen?
42.
4, 2. So this is the coordinate 4, 2. And then, of course, we have our arrows, which are going down and to the left, and going up and to the right. Okay. That's really all we need to know about this picture. The rest of it, we can just pull information out of it. So let's start with domain. What is the domain of this function?
The domain of this function is negative infinity.
To infinity. That arrow is pointing all the way to the left. This arrow is pointing all the way to the right, and there's a graph all the way through between it, so it's negative infinity to positive.
Oh, I thought I was wrong because you didn't say anything.
Just clarifying.
Oh,
And you sounded doubtful.
yeah, because you made me feel like
You sounded doubtful before I did anything.
Oh, no, I know. I got this.
Okay. So, all real numbers can get plugged into this function. Range, how far down does it go?
The range goes all the way down to
Negative infinity. What's the top part of it?
positive infinity.
Positive infinity. So this range is also all real numbers. So you can plug in any number that you want, plus you'll get every answer that you could possibly imagine. All right, so that leaves us with increasing and decreasing. So when is this graph going uphill? When is this graph going uphill? As we move, you have to go in that direction. You have to go left to right. So don't worry about where the arrows are going. Just put your finger on the graph and move. So as I move to the right, this part is going up. So here's one piece of my increasing, all the way up to this point.
So it's negative infinity to 6.
Negative infinity. Why negative infinity? Because it's pointing down? No, that's not why. It's not because it's pointing down. It's because it's pointing to the left. Because we're talking about x values here. So I can care less about up-down motion, other than that it's going uphill. I don't care about that. And it's coming from negative infinity all the way up to? See, you lost my train of thought. I'm moving left and right. I can care less about the 6.
We want the x value.
So negative infinity until
negative 2.
here, which is negative 2. So it's increasing from negative infinity to negative 2. Again, I could care less if you put a parentheses or bracket here, but I'm going to put a bracket.
Right, because that's where it starts.
Is it going uphill any other place?
Yes, it is.
Where's it start?
It starts at 4.
This 4-2 point, and it goes off this way, right? That's increasing. So it's increasing from
Bracket 4
bracket 4,
all the way to positive infinity.
positive infinity because it's pointing up, or positive infinity
To the
because it's
right.
pointing to the right.
To the right.
To the right. Because these are x values. The only time you talk about the y-axis is range. Everything else is x values. All right, when is this graph decreasing? Well, it's decreasing as we come across this part of the graph. It's going downhill.
So it's going to be negative 2,
So it starts at negative 2, and it ends at
4,
positive 4.
brackets,
X values.
brackets.
Brackets are parentheses, exactly. Here it goes. So this would be the domain range increasing and decreasing of this function. Yay!
X values.
So, just a silly question. If f of x is equal to 2, what am I asking for?
If f of x is equal to 2, you're looking for the y.
I'm looking for the y, so how do I find it?
Go up to 2,
Go up to 2, which is right here.
and then where does it meet?
Draw a horizontal line. How many times does it cross the graph?
Well, technically twice.
Twice. Literally, it hits right here. 4-2, right?
Right.
That's too high. So one of my answers is
4, 2.
4,
Oh, sorry.
because I'm looking for
The
x.
other one's negative 5.
And then this one over here, it's probably not going to be exact.
Yes, it
Like
is.
crosses
Negative
Oh, is it?
5. Negative 5.
Oh, it does. Negative 5. So my answers would be x is equal to 4 and negative 5. Make sure you put squigglies and not parentheses. Parentheses would represent a coordinate or an interval. So squigglies means individual values. Yay! All right, how about this silly question? What's f of negative 2 equal to?
2.
No.
You're looking for the
What's negative 2 represent?
x.
The x. And
So
f
you're
of negative 2
looking for the
equals?
y.
6. It's a coordinate. Negative 2, 6. Negative 2, 6. These are always going to be coordinates. All right, let's get on to the next picture.
No, what's that?
The pictures just get worse as we go.
The drawing's better.
Thank you. I'm following the diagram. It makes life easier. This picture.
Are you still on the side?
Same side. This is the W-looking thing. Okay. How many important points are on this graph?
Let's see. 1, 2, 3.
There's 3, right?
Mm-hmm.
For some reason it didn't pick up on my thing over here. It still didn't pick up.
The first one's gonna be 3.
There we go. All right, so there's 3 important points. This coordinate here,
Negative 3, negative 8.
negative 3, negative 8. This point right here,
0, negative 4.
0, negative 4. This point here,
2, negative 5.5 and a half.
really?
Yeah, it's kind of ugly. It's not even 5.5.
I thought I had these perfect. Oh well. Negative 2,
Negative 2.
positive 2, negative 5.5-ish. Something like that. I'll fix my pictures. I thought I had these perfect. All right, what's the negative 3, negative 8 called?
It is called a,
Maximum decrease.
it's a maximum, local.
Maximum.
No.
Maximum would be on top of everybody.
Minimum.
It's at the
It's
bottom
a
of
local
everybody.
minimum.
So this is not, it's a local minimum, sure, but it's also
Absolutely.
absolute. There is no point smaller than this point. Do you see any other graph that goes lower than this one? Nope. So this one is actually an absolute min. All right. What about 2, negative 5.5?
That's a local. That'd be a
That's a local min because he's lower than him. So this would be a local min. It happens at 2 with a value of negative 5.5. What about that point 0, negative 4?
Max, absolute maximum.
Is it an absolute maximum?
No, well,
What is the highest
Well,
point?
it's
He's the
highest
richest
level.
person in his neighborhood, but what about these people on the left and the right?
Yeah, those would be the absolute.
Yeah, they're going off to Donald
That's
Trump
the
land.
local.
So he's a local max. Because he's not the richest person in the world, he's just the richest person in his neighborhood. Alright. So let's talk about domain first. So the domain of this function.
It's gonna be
-8.
no. It's gonna be
Negative infinity, positive.
Negative infinity, positive infinity.
'cause it's-
Why? Because this arrow is pointing to the left, this arrow is pointing to the
Right.
right, and everything in between is covered. Okay. What about the range?
The range is gonna be negative.
Is that negative infinity, positive?
Is it negative infinity? Is this graph going through the floor?
No, so it'd be positive. but it's
Don't worry about
negative.
positive
It's
side.
not.
Start at the bottom. How far low does this thing go?
-3.
No, it is not
Negative
-3. It's -8.
Ah,
Because range is asking
the
for
Y.
the y values, not the x. It's the only one that does. How far up does it go?
Positive infinity.
Positive infinity. Not once, but twice. Once on the left and once on the right. That's okay. What about increasing? When is this graph going uphill as we move from the left to the right, as we move along this graph?
When is it going up?
When is it going up?
Negative infinity.
Now, as you move from the left to the right, are we going up here? No. Then, how about here?
Yes.
Yes. So we're going to count this little interval right here as increasing. So when is it happening?
From -8 to -4?
See, there's a problem here. The only time you look at the y coordinates is if you're talking about range. Everybody else has to be x.
So we need to think
Negative
X on
three.
everything
Only
is set.
The only time you talk about y values is range. Every other time you ignore y values and you concentrate on x. So when is it increasing?
Negative 3,
Zero.
0.
To 0. Is it increasing anywhere else?
Yes.
Yeah, it's increasing here. As we move left to right on this graph, it starts going up through this interval. So what is that interval?
+2
+2 to
infinity.
infinity along the x-axis. Not because the arrow is pointing up, but because the arrow is pointing to the right. Phew, it's like
So the
pulling teeth.
decrease is the other two that are left.
Decrease. You could think of it that way. It's the other two that are left, and then just try to figure them out. Or look at your picture. This part is decreasing. What interval is that part?
Negative infinity
Negative infinity because it's going to the left
to -3.
to -3 on the x-axis. Where else is it decreasing? Well, here, because it's going downhill.
So 0 to +2.
0 to +2. And that would be your decreasing interval. Now, if you put them all together, negative infinity to -3, -3 to 0, 0 to 2, 2 to infinity, that's everybody. You have all the pieces and you put them together and you get the entire domain.
Yeah, I bet I could make 100 on a test if I got up on the board and did it myself.
Yeah,
I do it on
probably.
paper. I do it on paper.
Something about paper. F of x is equal to 2.
I was to write this equal to 2.
What do you do?
-5.5.
You look for the x.
We're looking for the X.
See, this value is
So you go
Wow.
into 2
y.
and draw
This
a
value
line.
over here
Oh,
is x. So when I'm looking for the y coordinate, I better go onto the y-axis and plot a 2 someplace up here. Draw a horizontal line. How many times did it hit the graph?
Twice.
Twice, here and here. So there's going to be 2 answers. Approximately
-5 and
-4.5 and
negative
What?
3.
I would say negative 4 point something.
negative 4 point something,
And positive
3.5.
3 point something.
Uh-huh.
So I would approximate it. So x is approximately negative 4.5 and negative 3.5.
Oh,
Positive 3.5.
I'm gonna have to stop listening. You're right.
So here, this would land about 3.5. This one over here would land about negative 4.5 on the x-axis. Trick question. Someone wanted to say negative 5.5.
F of what is it?
F of what is what?
F of 0 equals
Negative 4.
negative 4. Okay. F of 2 equals
F of 2.
negative 5.5. These should be these ones. F of negative 3 equals
Negative 8.
negative 8. When a number's on the inside, it's the x coordinate, and you're looking for the y coordinate. All right. Oh, by the way, on my test questions, they're not approximates like this. They will land exactly. So they won't be approximate solutions. They will be exact solutions. All right, last picture. Probably the worst one.
Yeah, all them jumping and skipping.
Yeah, it's a piecewise function.
What'd you call it?
Piecewise. Why? Because it's in a bunch of
Piece.
pieces. So here's a piecewise function, and it looks something like this. It starts up here someplace, goes off in that direction, has this little piece here, stops there, has a little, goes up, and then it comes down. Okay.
Bring that arrow in some down there. The first one.
What's that?
You got coming down a little too far. Bring it down this way.
You got the wrong angle.
Fine. It'll live. Where's my garbage?
It's out in the hall.
Great place for it. Okay. Got it too far. That was nice on this one. It made everybody solid circles. There. That looks a little bit better. Okay, what are the important points on this one? Yeah. This one's important.
That's an important
Yes, it is. What is this?
Negative 2, positive
Negative 2, positive 1. This one here?
1, 0, 4,
0, 4. This one?
0, wait,
3, 4.
3, 4. This point?
5, 5,
5, 5. And one more important point.
8, 2.
This point up here is a maximum. Is it a relative or local? I'm sorry, relative or absolute?
It's an absolute.
It's an absolute. No other point on this graph is going to go higher than this point.
So you
Which happens at, what is it?
6, 6,
6, 6. Too many repeated numbers. I hate that. Oh well.
Absolute.
And it is an absolute
max.
max. It is the highest point of this entire graph. There is no absolute or even a relative min for this graph because it just goes off to negative infinity. Piecewise function. Okay, so let's start with domain. What is the domain of this function?
Negative infinity
Goes all the way to the left?
to positive infinity.
Nope.
Uh-oh.
Because as you travel along the graph,
To 4.
you get to this point. Is there anything between this point and this point?
No, we gotta do some
There's a jump here, right? So we got to be careful. So it stops here. So I say negative infinity until
negative 2.
negative 2, and it stops there. Where does it pick up again? Union.
A union, it picks up again at 0.
0, and it goes until
4.
4, and it stops there because there's a gap between 4,
3.
3.
Wait,
Yeah, 3.
3.
It starts at 0 and it goes until 3. So that would be this piece, but between here and here, there's absolutely nothing. There's a void. So it goes until 3, stops, and we have to union one more piece.
Oh, you said 5,
Okay, so the
6.
next
one will be.
It starts at 5, this x value at 5,
And then ends at the x value 6.
and it ends up at
Positive
infinity. Even though that arrow's pointing down, it's still pointing to the right. So it starts at 5, the x coordinate, and it goes off to positive infinity.
Wow.
So anytime you have to pick up your finger and put it down someplace else and it skips over x values, you're going to have pieces. That's why this is called a piecewise
I
function.
just don't understand the 6, 6. What does that have anything to do with
It's just an
domain?
absolute maximum. It has nothing to do with the domain. It's part of it, but that's about it.
Okay.
What it is going to change is for increasing and decreasing. See, over here, this 2, -5.5 didn't help with the domain or range. It was just part of the change from decreasing to increasing.
Okay, so
Those points
I get it
become
now.
changeovers.
it just kind of goes up past the 6, 6, and it's infinite.
So you're traveling along here, and it goes past it, and it just keeps on going.
Yeah.
And x values go off to positive infinity. All right, what about range? How far down does this graph go?
Negative infinity.
Both of them, over here and over here, are both going to negative infinity. So the graph is coming up, coming up, coming up, coming up. When does it stop?
To -2. I mean,
Stops at
6.
It stops at 6. Even though these pieces are here, as you travel up, there's a graph at least once on the left or the right of my arm. So as you come up from the bottom, you don't miss any values of y until you get past 6, 6. And then that becomes your range. So that would be negative infinity all the way up to 6.
So we're looking at the y value.
Y values. So your eye should be going left, right. Just looking for a graph as you move up. The up and down motion is much more important, but you have to see the whole picture. So just because this one stops at -2, 1 is irrelevant because this one keeps it going. And this one, it only has one y value, which is 4. And it's over here, and it keeps going until you get to 6, 6. All right, when is this graph increasing? Well, it's definitely increasing here because it's going uphill. So when is it increasing?
Negative infinity.
Negative infinity all the way up to
-2.
-2. Don't be looking at that 1. That's a y value. It stops there. Where else is this increasing?
A union at, it increases again at
5,
5.
This 5
6.
to this 6. It's going uphill on this little piece right here. So that would be union, bracket, 5 to 6, bracket.
That's
All
all
right.
increasing.
When's it decreasing?
6.
It decreases at
Positive
6.
infinity.
Starts at positive 6 decreasing,
And then goes to positive infinity.
Positive
positive infinity. So it's decreasing. It starts at
6.
positive 6 and it goes off to
Negative. I mean positive.
which one?
Positive.
Positive
That's
infinity
to the
because we're
right.
talking about to the right. So positive infinity.
That's the one time.
We have a problem. If I put my increasing and decreasing together, it's not the entire domain. I have arrows, green arrows on this one. I have black arrows on this one and green arrows on this one. What about this piece?
It's neutral.
Yeah.
Neutral. That's a good way of saying it. It's neither going up nor is it going down. We're going to call that constant. It's very rare to have a constant graph. You have to kind of force it into an idea or into a picture. A constant function has no upward motion nor downward motion. It's just flat. Very boring, you know. It's kind of like my pay for the last 3 years. Very flat. No raises, no nothing. So when is this thing constant?
0 to
0 to...
3.
Well, you were about to say 4, weren't you?
No, I was going to say 3, but
0 to 3.
because I didn't know if we were looking at X
Because
or
we're
Y
only looking at
values.
X values.
Ah, it's all X values.
X values.
Everything is X values except for
Range.
range. He's the only one that you say Y-axis values for.
Okay, let's do some F of whatever.
Oh, good God, why?
Because it's more practice and it's making me get it.
Fine.
Looks like you wasn't gonna do it.
F of X is equal to -4. What am I looking for?
Looking for X.
So I'm going to say X is equal to some values. I know there's going to be more than one. Why? Because down here at -4, if I go left and right, I'm going to hit the graph twice, which happens at approximately
-4 point something.
-4.5, I would say. It's actually pretty close to -4.5. What else is it close to?
9.
About 9.
-9.
Huh?
Is that? That's sorry, that's positive 9.
Which one?
Wait a minute, where are we at now?
You're at -4 and you're going to the right.
Positive 9.
Positive 9, because you're going to the
Right.
right. There. Whew. Okay, that's not hard. Okay, more than that. Above and beyond just pictures and domains and ranges and increasing and decreasing.
So we're done with this.
And maximums and minimums. Personally, I think this is the easiest question on the test because all you have to do is look at the picture and take the answers and put it on your paper. You don't have to do any work whatsoever. No calculations, no nothing. You just have to use your brain.
Oh, it is.
It is?
Yeah.
Oh, I don't feel it.
You made it wrong.
Now there is a small little piece in here that I could care less about, even in odd functions, but I'll talk about it. Just in case you run into it later in life.
I doubt it, so we don't have to.
I doubt it. I just want you to be able to do all your homework rather than going, oh, Mr. Gordon, you never covered this. Jeez. So, even and odd is defined this way. If f of negative x is equal to the original function, we call this even. We call this even.
Say that again.
If you take negative x and plug it into your function and you end up coming back to the original function, then we consider that function even. Talk about it a little bit more in a second. If I take f of a negative x value, and I plug in negative x into a function, and I end up with opposite of my original function, we consider that odd. The sad thing is, not very many functions are even or odd. They're generally just neither. They're generally just neither. These are just special kinds of functions. Now, if you're talking about an even function, let me give you a coordinate. Let's say I have this point here, 3, 4. And this is part of the function f of x. It is a point on the graph of f of x. If f of x is even, what does that mean? Well, that means if I plug in 3, I'm going to get 4. That's from this one. But if I plug in negative 3, what am I going to get? Positive 4. Because it's not changing the y value, it's just changing the x. The x is the only one changing here. So this means that the point is over here someplace. Negative 3, positive 4. How would you describe these 2 points? Well, it's moving, reflecting over the
Over the y-axis.
over the y-axis. So this is also known as a reflection over y-axis. So if you have an even function, the graph of it is reflected over the y-axis. So this last graph that I do, is it even, odd, or neither? Trust me, the answer is usually neither. Because if I take this point 5, 5, there is no negative 5, 5 over here, so it's definitely not even. Now, what does it make it odd? Odd's a little funnier.
So that right there was an even example.
Yeah, that's an even example. This is an odd example. If I start off with the same point, 3, 4, someplace over here, and this is my odd function, f of x, when I change 3 to negative 3, what happens to the y value? It becomes negative. So instead of getting 3, 4, I would get this point down here, negative 3, negative 4. And it's considered odd because it reflects through, this point, the origin. It reflects through the origin. So this reflects through origin. Very few graphs are odd. Obviously this one is not odd because here's 5, 5, and there is no negative 5 on the other side. So one reflects over the y-axis, that would be an even function. The other one reflects over the origin, and that would be an odd function. Okay, so let me draw you a couple pictures here. Tell me which one is even and tell me which one is odd. It's real easy. This graph. And this graph.
A is even, B is negative.
Odd.
Odd. Even negative.
This graph is even because whatever happens on the left also happens on the right. And this one is odd because whatever happens in the top left happens in the bottom right because it's going right through the origin. So this graph would be even, and this one is odd. But it's not super important unless you get into polar coordinates and graphing pretty polar pictures.
On that odd example, you don't have, is that arrow supposed to be going through that point? Or
Well, I'm just saying that it's reflecting through the point. This is not part of the graph, this blue line. I just kind of showed you that it's moving over.
Okay.
People don't see points moving, they see segments. Like, the letter A is considered an even letter. I can't think of any odd ones. Z, I guess Z would be an odd one. If you think about it. Z is an odd one because it reflects to that point. The top right goes to the bottom left, the top left goes to the bottom right. It reflects through that point right there. Alright.
It's like symmetry or symmetric or whatever.
It's very symmetrical. Yeah, it's kind of like symmetric, except most people don't see the odd symmetry. Most people see the even symmetries and the axis symmetries. Okay, so what does that leave us? That leaves us with piecewise functions real quick, and then on to the next stuff. How much time do we got? Plenty of time. Okay, so piecewise function. I've graphed the piecewise functions for you, but it's actually different when I give you a piecewise function. For instance, you all know piecewise functions, by the way. When you go work at a job, no, that's probably not a good idea. If you make a phone call, how much do they charge you for 10 seconds? Say 25 cents. How much for 20 seconds? 25 cents. How much for 30 seconds? 25 cents. How much for 59 seconds? 25 cents. What about 1 minute? 25 cents. 1 minute and 1 second. 50 cents. So what happens is you pay the same price for an entire minute, and then all of a sudden at the end of it, it jumps up and it creates this other line. So you get something that looks like this. Here's the beginning of your phone call. You don't get charged anything because it hasn't connected. It's just ringing. But once it connects, you get charged 25 cents all the way up to 1 minute. After that 1 minute, it jumps up and it gets charged 50 cents until you hit 2 minutes. And then it jumps up and it charges you 75 cents until you get to 3 minutes. This is a piecewise function because the graph is not connected in any way. It's also called a step function. It looks like the stairs going up. Oh, it's fun to be that way. No one's imaginative. It looks like steps.
Oh, yeah.
Okay. Just kind
I
of.
still don't see it.
Oh, go away. So if I define a piecewise function, it's going to look like this. You're going to have these little functions, and off to the right of them, these things over here, these are ifs. Those are the ifs. Pretty much it says this. If I want to evaluate f of -2, if f of -2 is less than -3, I'd use the top one. Is -2 less than -3?
Is -2 less than -3? No.
No, so I'm not going to use this. If -2 is between -3 and 4, I'm going to use x squared minus 1. Is -2 between -3 and 4? And the answer to that is yes. We're going to watch what happens in the bottom one. If -2 is greater than 4, I use this 2x plus 3. Is -2 greater than 4? No. So the only one I get to use is that middle one. Trust me, you only can use one piece. Why? Because this is a function. And for every x, there is only one y. So if I plug it into two of these, I'd be getting two different y's, and that'd be wrong. So f of -2 is going to equal, I go to the middle one, something squared minus 1, and that something happens to be -2, and -2 squared is 4 minus 1 is 3. So f of -2 is 3. Okay. What about f of 5? Well, is 5 less than -3? Nope. Is 5 between -3 and 4?
No.
Nope. Is 5 bigger than 4?
Yes.
Yeah. So I'm going to use the bottom one, which is 2 times something plus 3. And that something is 5. And 2 times 5 is 10. 10 plus 3 is 13. And there's your answer.
So those are like formulas that we need to say.
Pretty much, yeah.
Okay.
And then if I say, well, what's f of negative 6? Well, negative 6 is not bigger than 4. It's not between negative 3 and 4, but it definitely is less than negative 3. So my answer is
2.
2. I don't even have to do any calculations.
So you don't have to do any calculations.
Because it's constant. For any x value, it's alwaにgoing to be 2, which is that middle part of that last graph we had. Okay, second thing I want to do with that. I want to graph it.
Do you have to?
Yep, why not? Oh, by the way, what if I asked you what's f of negative 3?
X is less than negative.
Is negative 3 less than negative 3?
No.
Nope. Is x negative 3 between negative 3 and 4 inclusively?
Yes.
No.
No.
It doesn't have the equal sign
Oh,
there.
doesn't have
It doesn't have the equal sign there. Is negative 3 bigger than 4?
No.
Can I plug negative 3 into this function?
No, because it's not.
No.
Not in domain. Negative 3 is not in the domain of this function. I have removed it, thrown it away, kicked them out.
So it's going to be
It's nothing.
a circle.
No, it's, well, in the graph it's going to be an open circle, definitely. All right, so let's graph this thing. Now what's important about this graph, I'm not sure how well this is going to work since I made it up. Hopefully it works okay. We'll see. If we're going to graph this thing, 1, 2, 3, 4, 5, 6, 7, 10. I usually don't go 10 by 10, but I have a feeling this graph goes pretty big. I highly suggest if you're dealing with a piecewise function that you concentrate on the domains first. The domains have breakpoints at negative 3 and the important numbers up here are negative 3 and 4. So on the graph, I highly suggest you put in dotted lines at negative 3 and positive 4. Basically what this is saying is you're going to get 3 different pictures. You're going to get a picture to the left of negative 3. You're going to get a picture between negative 3 and 4. And you're going to get a picture from 4 to infinity. So you're going to have these 3 pieces of this graph. Now the top one is the easiest one. It is technically y equals 2. Y equals 2 for any x value. But it starts at negative 3. And here's y equals 2. We would start here and go this way. You get this open circle here. Why is it open?
Because it doesn't have the line up on it.
It doesn't have the equal part of it. So it's an open circle, and for every x value to the left, y is always going to equal
2.
2. So you get this nice little horizontal line. And literally the equation of that line is y equals 2, but we'll talk about that later. All right, how would I graph x squared minus 1 between negative 3 and 4? What would you do? This goes back to your first question of the class day.
You make a table.
You make a table. If you don't know how to graph something, table it. So I'm going to come over here and I'm going to do a little table. And I'm going to have my x, and I'm going to have something squared, minus 1, and I'm going to generate a bunch of y's.
I thought
And
I'm sorry, but I thought we determined that 1 wasn't even a function of it in all those other those numbers that you gave for x.
No. These all turned out to be functions. This one just wasn't in the domain. They're all functions. This whole thing is a function. That's why I call it a piecewise function. I mean, once you label it a function, then certain things have to be true about it. All right, what x value should I start with?
Negative 3.
Negative 3. It tells you where to start. So you put in negative 3, you get 9 minus 1, which is 8. You plug in negative 2, and you get 4 minus 1, which is 3. You plug in negative 1, you get 1 minus 1, which is 0. You plug in 0, you get negative 1. You plug in 1, you get 0, and so forth and so on. It'll be 3 and 8, by the way. Well, how far do we have to go?
To 4.
4. 4 is 16 minus 1, which is 15. Ugh. So we're going to get this 415 down here. Okay, we can plot these points. Alright, the first one was negative 3, 8. So negative 3, positive 8, which is here. Open circle or closed circle?
This is, on the 3 side is open.
It's open because negative 3 is not included. So this point right here is going to be an open circle right on that dotted line.
So what is that on now?
That's on negative 3. That's why I put these dotted lines
Well,
in
why
here.
did you go all the way up?
Because it's
3,
8.
3, 8, I'm sorry.
Negative 3, 8. The next one is negative 2, 3. So here's negative 2, 3. That's actually a solid point. Negative 1, 0, which is right here. 0, negative 1, 1, 0, 2, 3, and 3, 8. And then the next one is like 15, but it's up here and it is a solid circle. And you get this picture. Ugh, that's horrid. But it stops right there. There's no arrow at the end of it. It stops dead. Alright, so you get this line coming up to here, and then you get this nice little picture in here. The last thing to draw is 2x plus 3. If you don't know how to draw 2x plus 3, table. But I'm just going to draw it really quickly. Plug in 4. 2 times 4? 8 plus 3? 11. So it's going to start right about here, but it's going to be an open circle, and it goes up like that. And it does have an arrow at the end of it. So this would be a piecewise function. So when in doubt, do tables with the domain involved. That's all you have to do. Plot points and graph. I know, it looks horrid. It's not that bad. We're going to skip the last part of this, different functions, and jump into 2, 3.
So make sure your homework is on that.